Hello Legacy Sabers, Marsh here. So today we're going to talk about solving quadratic inequalities. What you're going to want to have on you, you're going to want your notes, foldable, and then you may need a calculator just to do really simple computations today. First, our objective of the day. Ultimately, we just need to be able to solve quadratic inequalities representing your answers in interval notation. Now, first we got to talk about the steps for solving these quadratic inequalities. So step one, we're going to write the original inequality as an equation. So we're literally just going to get rid of the inequality sign and put a equal sign there. We're going to set equal to 0 if it's not. So we're going to have to do some solving probably. So it's equal to 0. Factor what we get, and then we're going to solve those factors. We're going to plot the points on a number line and then test points in each interval back into the original inequality. We're going to write the answer where we got true in the interval notation. I know it sounds kind of confusing, and it looks kind of confusing, but honestly, it's not terrible. So go ahead and write these steps down. You might need to pause the video. Let's continue. First example. 4x squared plus 8 is less than or equal to 33x. So first step I'm going to do is I'm going to make that an equal sign. Okay. Now I'm going to get it equal to 0. So I'm going to move this 33x over to the other side. There we go. Plus 8 is equal to 0. Now I get to factor over here. First thing I look at is there's no GCF, which is a sad day. So I literally have to do trinomial factoring. 4x squared, good way to make 4x squared. Let's say a 4x and an x. Let's go an 8 and a 1 to make 8. 4x times 8 is 32x. 1 times x is 1x. Oh, both of those being negative will make me 33x, so that'll work. So my two factors that are factored, after I factored this equation, I get 4x minus 1 and x minus 8. Now, I need to solve those. So I'm going to set 4x minus 1 equal to 0. Do a little quick math in my head, and I get 1/4, correct? Because you add 1 divided by 4. If I set x minus 8 equal to 0, I'll get x equals 8. So these are my two border points that I need to place on my number line, since this is ultimately an inequality, right? So I'm going to set 1/4 and 8 on this number line. And what I'm going to do is I'm going to come up with some, let me go find my changing of color here. I'm going to come up with some numbers that are in each interval. So I need a number less than 1/4, between 1/4 and 8, and bigger than 8. So less than 1/4, 0, right? 0 is less than 1/4. Between 1/4 and 8, 1. And then bigger than 8, I'm going to put 10 in there. I could do 9, I'm just going to do 10. So what I'm going to do is I'm going to substitute this number, this test value I decided to pick, into the inequality and see if I get a true statement. So 4x squared, so 40 squared, well, that's just 0, right? Plus 8, I would get 8, is less than or equal to 33 times 0, which is 0. So is 8 less than or equal to 0? No, right? So I'm going to put a no in that spot. Now, do the same thing. We're going to plug in a 1. 4 times 1 squared. Well, 1 squared is 1 times 4 is 4 plus 8 is less than or equal to, well, 33 times 1, that'll be 33, right? Well, 4 plus 8 is 12. Is 12 less than or equal to 33? Yes, right? That's yes. So we're going to write a yes in the middle there. And then we're going to test 10. So 4 times 10 squared. I'm going to have to write this one out just a little bit more because I don't think I can do that one in my head. 10 squared is 100 times 4 is 400 plus 8 is 408. Less than or equal to 330, it looks like. So is 408 less than or equal to 330? Nah, right? That's no. So what I'm going to do is I'm going to make a little no. So now I want to find where did I say yes, which it looks like I said yes here in the middle, right? Right here is where I said yes. So my interval of answers that work in this particular inequality right here is between a fourth and 8. So what I'm going to tell the user, or my answer, is 1/4, comma 8 is my interval. And since I can be equal to those values, right, because we have an equal sign, I'm going to put some brackets for my interval notation. And this is my final answer. Is it a lot of work to get to that final answer? Oh my goodness, yes. But we found the final answer. So my answers to this inequality lie between the numbers 1/4 and 8. Let's try another problem. 5x squared plus 10 is greater than 27x. Again, I am going to make it an equation, and I'm also going to make myself equal to 0. So 5x squared minus 27x plus 10 is equal to 0. I do not see any GCF, so it looks like I just got to jump in and factor right away. Well, it's got to be a 5x and an x, right? Because that's the only way to make 5x squared. To make 10, 5 and a 2, 5x times 5 is 25x. 2 times x is 2x. Ooh, 25 plus 2 is 27. If I make them both negative, I'll get that negative 27 that I'm looking for. Now I got to set those two things equal to one another, or equal to 0, excuse me. So that one equal to 0, set that one equal to 0. I will get x equals 2/5, and x equals 5 is what it looks like. Now, since it's an inequality, I'm going to go back to the inequality world and set these on a number line. 2/5 is definitely smaller than 5, so 2/5 is over there, 5 is over here. I am now going to go change my color here so you guys can see what I'm doing. Number smaller than 2/5, I need some test values. That would definitely be 0. I always pick 0 as long as I can because it's the easiest number to plug in. Between 2/5 and 5, well, 1. And then bigger than 5, let's go 6. Now, I could pick, honestly, any number between 2/5 and 5. It doesn't matter. It could be 3. It could be 4. It could be 3/5. I'm just picking numbers that I know are in between those two. Let's plug them in. So I got 5, 0 squared plus 10 is greater than 27 times 0. This would be 10. I'm going to do like this. 10 is greater than 0. That's definitely a yes, right? Because 27 is bigger than 0. Now let's plug in a 1. So 5, 1 squared plus 10 is greater than 27 times 1. 1 squared is 1 times 5 is 5. Plus 10 is 15, is greater than 27 times 1, 27. That's a no, right? 15 is not bigger than 27, so there's no here. Now let's test the last one. So I'm plugging in a 6 is the test value we chose there. So 6 squared plus 10 is greater than 27 times 6. 36 times 5 is, let me grab my calculator here, 36 times 5, 180 plus 10 is 190. And that is bigger than 27 times 6, which is 162. Is 190 bigger than 162? Yes, indeed it is. So I have a yes on the far right. Now notice, where do my yeses exist? I have a yes on this side, and I have a yes on this side. I don't have that middle piece. That middle piece was a no. So the numbers between 2/5 and 5 do not satisfy this particular inequality. So now I'm going to write my interval notation. Well, I have all the numbers less than 2/5, which I'm going to write as negative infinity to 2/5. Now, 2/5 does not satisfy this inequality because it's not an equal to, right? So I'm going to put a parenthesis around my 2/5. Then I'm going to say within union of my next number that starts with 5. Again, we're not equal to 5. That does not work in this inequality. And then to positive infinity, I go forever. Let's try one more inequality, one more problem here. Ultimately, I have x plus 3 quantity squared is greater than or equal to 2 parenthesis x squared plus 7. First thing, I am going to do a little sidebar combo. X plus 3 quantity squared is the same as x plus 3 right? Which is the same as x squared plus 6x plus 9 after I do my foiling. I'm going to rewrite that out because I do not want that to stay like that. I kind of want it so it's easier for me to factor. So I'm going to rewrite that problem here. I'm also going to make this an equation so I don't have that inequality scaring me. And then I'm going to distribute that 2 in. Okay. Get everybody over to the same side. Now, I could move the 2x squared to the other side, but then I get a negative x squared, and I don't really like negative x squareds. They're kind of difficult to factor with. So I'm actually going to be kind of silly, and I'm going to move everybody from the left over to the right. I know it kind of looks weird, but honestly, I like to have a positive x squared. So I'm going to get 0 equals x squared minus 6x plus 5. Now I need a factor. No GCF hiding. X squared would be an x and an x. 5 is a 5 and a 1. Easy factoring going on here. I need a negative 6, so both negative. Solving those two equal to 0, or setting each equal to 0. I get x equals 5, and I get x equals 1. Again, I need that number line. 1 goes here, 5 goes there. Now I'm going to go pick some numbers that are between 1 and 5 and some outside guys. So 0 is definitely less than 1. We're going to go 3 in the middle, and then we're going to go 6 on the outside. So now, gross, right? I'm going to have to plug them all into this inequality. That's all right. We got this. So 0 plus 3 squared is greater than or equal to 2. 0 squared plus 7. All right, so 0 plus 3 squared, well, 3 squared is 9, is greater than or equal to 0 squared is 0 plus 7 is 7 times 2 is 14. So is 9 bigger than or equal to 14? Nah, right? That's a no. Let's try plugging in 3. Let's see if the middle is where an answer can lie. There we go. 3 plus 3 is 6. Almost did multiplication there, guys. 3 plus 3 is 6. Squared is 36. 3 squared is 9. Plus 7 is 16. Times 2 is 32. Is 36 bigger than or equal to 32? Yes, right? That's a true statement. So we're going to say yes there in the middle. Now we're going to plug in 6, the big number. All right. 6 plus 3 is 9. Squared is 81. 6 squared is 36. Plus 7 is 43. Times 2 is 86. Lost where I am. There we go. 81 is greater than or equal to 86. No, right? That is definitely a no-go. So I'm going to write no here. Okay, so where did I say yes? I only said yes in the middle, right? So right here is where my yes is. So my answers to this inequality exist between the numbers 1 and 5. So I need to tell the user that, or tell my answer of 1, 5. But it is equal to, right? So again, I have those brackets because I can include 1 and 5. If I plugged in 1 to this inequality, it would become a true statement. And that is the end of this video. I will see you later, Sabers.